Okay, on to the next page. Hello, zebras. Equations. Yesterday we talked about that. Remember, an expression is a part of a math sentence that's like 3 plus 5 or 5 minus 3, or it just is a little expression. And then the equations mean that there's something on either side of the equal sign that are supposed to be balanced. It's like a scale. You may not have, if you've ever seen an old-fashioned scale where you have to put one thing on the one side and make it equal the other side, and they have to be balanced. Okay, so each side of the equal side has to be balanced. And remember, way back at the beginning of the school year, we talked about these different properties. Remember these? The commutative property. Remember, commute has the word mutate in it, right? And so they're changing, morphing a little bit. Associative property was, let's see, when you would take your associates that you work with and you pull them out. Okay, we'll talk about it as we go. And then this one, the distributive property. You know what distribute means? Means to like pass something out or to carry it out. So here's when we learned it a long time ago. The product of any two factors can be found by separating one factor into parts or add-ins. Multiply each part or add in by the other factor and add the partial products. Okay, so remember commutative, mutate. So which one of these are the same, only mutated on the other side? Like this one, 7 times 4 times 2 is the same as 7 times 4 times 2. I need to make sure I'm doing this right in my book. I think, okay, this is the one this is the commutative, okay? So it's this plus this is the same. When you look in the mirror, it's backwards. It mutates this to this. Okay, so that's the commutative one. Okay, there's 4 of these though, and only 3 of these, so we're gonna use 2 of these twice. So which ones of these look the same? Because there's gonna be one that there's 2 of. Does this look like associative? Were they pulling it apart? But this one here, they're distributing it, the numbers, onto either side with multiplication over addition. Okay, so this one has addition after you multiply. This one has addition after you multiply. This one has no addition in it. This one is when you associate. Like this is one workroom and these 2 people are working together and this guy's by himself, and then maybe after lunch they come back and these 2 are going to work together and this one's going to work by himself. That's what I said, to try to remember it that way. Associate, usually an associate is someone you work with. I don't know, I'm just trying to help. Okay, so that's the B. And then the distributing, see how they distributed 24 times 35? They took out the 30 and they took out the 5, so they divided 24 by 30 and then 24 by 5 and added them together. Remember, that was the distributive property of multiplication over addition. So these 2 are both doing that. Those 2 are C. Okay? It's not terribly important that you remember the names, but it really does kind of help us to think in different ways. All right, so then we're going to review some of the stuff we did yesterday, and we're going to work on some of that that distributed property of multiplication with addition. Okay, and again, we're doing greater than, less than, or equals. Can you see those okay? All right, so we have to know what 6 plus 3 equals. 6 plus 3 is 9, and then times 10. That would be 90. Okay, and what's 3 times 30? 30, 60, 90, also 90. So these 2 equal each other. Okay? And then on this one, A plus B plus C, A plus B plus C. Those are going to be the same because they're doing addition on all of them, so that's equal. Okay? 42 plus 5/5. What's 5/5 equal? 1, right? So this is like 42 plus 1, which is 43. And this one, what's 4/4? Also 1. Good. 42 plus 1 again. So these are also equal. Wow, all 3 of those were equal. I feel like I might be doing something wrong. Let me double check. No, those are all equal. Okay, 4/5. Oh boy, we haven't done decimals in a while. Are there any other these? I love how they do that. We haven't touched decimals in months, but they want you to try to remember what you remembered, what we've learned. So this one is 8/10, right? Because that's the tenths place. Tenths, hundreds, thousands. Remember this over here that we were working on. Okay, if it has one digit, it's tenths. Second digit is hundredths. Third digit is thousands. You guys did this towards the beginning of the year, and the leopards were doing it right before spring break. Or, well, no, they were doing it before, way before that too. So it's kind of a review for everybody. All right, so 8/10. Now, if we were going to reduce this, we divide both of them by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So look, 4/5 equals 4/5, and that means all of these were equals, which I checked, and it's right. That is correct. But the next two columns are not all equals, just some of them. Okay, and you know what? I'm gonna let you do the easy ones. These are easy to do. This is still 81 divided by 9. Remember, fractions are 81 divided by 9. That's division. Easy. Let me look at this. 7 through 16. I'm going to let you guys do the middle column. I'm going to do this outsides again. Okay, so 3 plus 2.5. Remember, all we have to do is add the whole numbers together. So 3 plus 2 is 5, and then plus another 0.5. So 5.5. And 32 plus 0.5 is 32.5. So this one is greater than, right? Can you see that, I hope? Yep. Okay. Then we have 140 divided by 2 and 150 divided by 3. So we're going to come over here and we're going to do this and we're going to do this. Okay. 2 doesn't go into 1. 2 goes into 14 7 times. 2 times 7 is 14. 14 minus 14 is 0. Bring down the 0. 2 goes into 0 0 times. Okay, and 0 minus 0 is 0. So this one right here equals 70. 150 divided by 3. 3 doesn't go into 1. 3 goes into 15. 5 times. 5 times 3 is 15. 15 minus 15 is 0. Bring down the 0. 3 goes into 0 0 times. 0 times 3 is 0. 0 minus 0 is 0. We have 50. Okay, so which one's bigger? This one. Okay, then the next one, m plus n plus m. That's that commutative property where it mutates on the other side, but they both equal each other, don't they? And then remember this, 10 to the second power. So that means 10 times 10. If it was 10 to the third power, that would be 10 times 10 times 10. Okay, so it's not just 10 plus 10, it's 10 times itself. 10 times 10 equals 100, right? And what's 12 times 12? This could be written like this too, 12 to the second power, because it's 12 times 12, which equals 144. So which one of these is bigger? This one, okay? So you guys do that middle column. I know you can do it. Now look down at the next section. It says part whole model. Okay. Part whole model. So we have n. This is addition. N equals 3 plus 5, so n would equal 8. This is subtraction. N would equal 8 minus 3. Multiplication is, n would equal 4 2's. And then the division is n would equal 8 divided by 4. Okay, the difference is that the n, this is very different than what we were doing before. I thought this was that other thing that we were doing, but it's not quite the same. You know what? I'm going to skip this for a second. Let's go over to the back real fast. We'll come back to that because I'm going to have to look at my book real quick because that's something different than what we were doing. I thought it was the same thing we were doing before. So I just need to freshen my memory and see how it's supposed to be done. Okay, then it says use mental math to match the expressions of equal value. Okay, So 2 times 4 in your head, that's what they want you to do, but you can do it on paper if you need to. Okay, 2 times 4 is 8, and we're going to add it to 7. So which one of those would be, it's 8 plus 7 is 15. So which one of these equals 15? So you're not looking for the problem this time like we did before. You're just looking for something that would equal. So we could say this equals 3 times 5 because they both equal 15. Do you see? So C would be here. So this time you're not looking for a problem to match this because they don't match, do they? 3 and 5 has nothing to do with any of those numbers, right? Okay, so that's what you're doing. So what would be on the other side of this equal sign? This would be 2 plus 9, that's 11, and 3/3. 11 and 3/3 equals what? 12. So this equals 12, so now we need to find something over here that equals 12. That definitely doesn't equal 12. This is 100 times 9. Let's do this, figure this out, because you might need these. 900, let me see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, you're going to use every one of these. So it'd be helpful to have these answers. 10 times 10 is 100. So these two together equal 1,000. So if we have something over here that equals 1,000, that's that one. What's 600 times 900? Remember, do the two zeros. 0 plus 0, 0 plus 0. 6 plus 9 is 15. So this one equals 1,500. 4 to the second power is 4 times 4. That one equals 16. And then do the parentheses first. 2 times 3 is 6. 6 times 2 is 12. Okay? So here's what each of these equals. Make it less confusing. Okay? And then we find out whatever equals that. That will help us. Okay? So 2 plus 9, 11, 12. Okay. So which one of these equaled 12? This one did. So we're going to use E right here. Okay? Then 500 plus 500 plus 500. They all have two zeros. And then just do 5 plus 5 plus 5. Or 5 times 3 is 15. So which one of these equaled 1,500? This one. Okay, so do A. Okay, 2 plus 2 is 4 times 2 plus 2 is 4. 4 times 4 is 16. So it equals D. So see what we're doing here? This would be 2 plus 2 times 2 plus 2 equals 4 because they both sides equal 16. See? Okay? Like I said, you don't have to have those numbers. Okay, and then 999 plus 1 is 1,000, which is B. I forgot to cross off D. But B is left. Okay? Then, let me make sure, can you see all those? Yes, you can. All right, so then the next section says to write the mathematical expression from the box that completes the equation. We're pretty much doing the same thing, only instead of writing CEADV, we're going to write the expression in the blank. Okay, so 3 times 3 times 2, same thing as we did up there. 3 times 3 is 9, times 2 is 18. So we need one of these up here that equals 18. Which one equals 18? If you want to, like the last one, you could go through and do all the problems first. You could even do that down here. Do all the problems first and then go up and match them. Okay, so this number plus 12 isn't going to equal 18. 72 plus 13 isn't going to equal 18. 50 divided by 2 is 25 minus 1, close, 24 but not quite. 3 times 6 is 18. So we're going to write that here. Okay, so see what you're doing? You're making the equation by putting a mathematical expression there. 3 times 6 is the same as 3 times 3 times 2. See? Okay, so we used that one. And like I said, let's go up here and see what these all equal. That one equals 24. Okay, this one equals 0 plus 2 is 2. I'll write that up here. 9 plus 1 is 10. Carry the 1. 5 plus 1 is 6. And 3 plus nothing is 3. Okay, so that one equals 3,602. This is 72 plus 13, which equals 85. So that one equals 85. 24, we use that one. That equaled 18. 60 times 60, do the zeros, 2 zeros. When we multiply, remember we have to use both of them. When we're adding, we just use one set. Okay, then 6 times 6 is 36. So this is 3,600. And then 45 minus 10 equals 35. Good. Okay, so now we have those answers. And now we can just go match them again. Okay, what would be the same as 100 times 36? So remember how we do this? We do the simple numbers and then the 2 zeros. So 2 zeros plus 1 times 36. So it's going to be 3,600. Which one equals 3,600? This one right here. Okay, cross it off and write it over here. 60 times 60. 60 times 60 equals the same thing as 100 times 36. Do you see what we're doing? Okay, 3,000 plus 600 is 3,600 plus 2. 3,602 is the same as this one. 3,590 plus 12. Okay, do you think you guys can do these last three on your own? I do. Make sure that you look up here. We used this one. So all you have left are these three. This one equals 85. This one equals 24. This one equals 35. So you just got to match them to them and make sure you write the expression out. Okay? So you guys finish that little section over there. Now let's look down here again. Did we do this today or yesterday? I think we did this. Yeah, we did this yesterday. Okay, so there's 3 boxes. I'll do the hardest one with you. I'll do the last one with you. And you guys are going to do the 2 easier numbers, okay? So you do those 2. Let me just refresh your memory how to do this again. Okay, we have to have something plus something that equals 72. So it could be 70 plus 2. Okay? Again, you don't have to have my answer. You can use your answer, whatever answer you come up with. Okay, minus, so something like, let's add 3 to this. 72 plus 3 is 75. So 75 minus 3 equals 72, or you can go higher or lower. Something that'll equal, these are the ones that are not as easy. I can think right off the bat of 12 times 6, but there's others too. 36 times 2, there's some others you could use. Well, I'll be quiet and let you guys come up with those on your own so I don't spoil it. And then something that's divided by that equals 72. That one you probably don't know. So you're going to have to do 72 times something to get that answer so you can go backwards with it. I'm going to do, let's make it a big number so it sounds important. Okay, 2 times 8 is 16. 7 times 8 is 56 plus 1 is 57. So 576 divided by 8 equals 72. Once you have the 3 numbers, you can put them in there. See? Okay, so you guys go back and do the other 2 boxes. Do this one and the one that was in front of it. Then we have 2 story problems. It says each 5th grader was given 1 box of 25 candy bars. Cool. To sell or buy them yourself. When I used to do this in school, I bought a bunch of them myself because I loved them and then I didn't have to sell them. Okay, so 1 box of 25 to sell. For the fundraiser at school, Grace sold 8. How many does she have left in her box? Okay, whenever you see left, a lot of time that's going to be subtraction. Okay, so 25, oh, sorry, it says to draw a picture. Where's the picture? You have to draw a picture over here. So over here, you need to have a box and draw 25 candy bars, however you want to. Okay, and then have like the 8 that she sold, maybe make those outside the box. 2, 3, 4, 5, 6, 7. These are the ones she sold to somebody and put the rest of them in here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, may have to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so how many are here then? There's 1, 2, 3, 4, 5 rows of 3. That's 15. 5 times 3 is 15. 16, 17, okay? So over here, it's 25 minus 8 equals n, or whatever number you want, what letter you want. And then n equals 17. That's how many she has left. Okay? So that's how you do that one. Look at page number 46. It says Jackson sold 2 boxes of candy bars and 3/5 of the next box. Wow, he was a big seller. Okay, so we had 17, now we have 18. I'm going to leave that there for a second, see if that helps us. 2 boxes of 25 and 3/5 of the next box. Oh, goodness. Okay, so let's continue our box. So you guys are going to have to draw a new picture. Draw a new box. I am doing it the fast way here. I'm leaving mine from last time. But draw another box and make sure it has 25 this time. This has 18, 19, 20, 21, 22, 23, 24, 25. 3/5. Sorry, I'm doing something in my head to make sure I'm doing this right. Because even teachers make mistakes. Okay. Okay, so here's one box. And then instead of drawing 2 whole other boxes, you could just put 2 boxes here. Okay, 2 boxes. Each of these had 25 candy bars. He sold 2 whole boxes and 3/5 of the next box. So in order to do that, we need to divide this into fifths. Okay, there's 25 in here. I wish I would have drawn it differently. Because what we need to do is we need to divide it into 5 parts, and he sold 3 of the 5 parts. So 25 divided by 5 would be 5. Okay, so I didn't do this a good way. Let me just redo it. We could have made it work, but I don't want it that way. This time, I'm just going to make dots, and it'll be faster. Okay, so 25 again, and this time I'm going to do it in 5 rows. 1, 2, whoops, gonna have to be closer. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 10, 15. 1, 2, 3, 4, 5. 20. 1, 2, 3, 4, 5. Okay, those are weird looking candy bars, but that's okay. All right, then we're going to divide this into fifths. So here's a 5th, here's a 5th, here's a 5th. 1, 2, 3, 4, 5. Fifths, 5, 10, 15, 20, 25, right? And it says he sold 3 of those. So 1/5 is 5, and it sold 3 of them. 1, 2, 3. So he sold 5, 10, 15. He has this much left. How many candy bars has he sold altogether? So 3/5 of it, we divided into fifths, and we're using 3 of that. Do you see? Okay, so 3/5 is 15 plus these. What's 50? What's 25 plus 25? I already gave you the answer. 50 plus 15. So we're going to write, let's see, for our equation, we write 2 times 25. Okay, that's these 2. Plus n equals, no, I guess we'd have to write plus 3/5 of, oh boy, let's just write the answer. I'm getting into stuff we haven't talked about. Okay, so let's just do this. 25 plus n equals y, because we have 2 unknowns. Nope, let's not do that either. Plus 15 equals 50, 65. I'm trying to make this as simple as we can. There's actually easier ways to do this with algebra that you'll learn starting probably next year, but then a lot of it in 7th and 8th grade, or I mean 8th and 9th grade. So there's faster ways to come up with this answer, but we don't know how to do that yet. So we'll go with this one. That'll work. 65 candy bars. Okay, I'm going to pause this and I'm going to make a part 2 because I want to go back and make sure I know what they're doing on that one section that we skipped, okay? So I'm going to pause this and then you'll have to click on part 2. This is part 1 and then part 2, okay? 1 second.